Okay, let's get started. Can you guys hear me?
So,
Okay, cool. Uh, yeah, let's get started. I will just share my screen. Can you guys see the screen as well? Hello. Okay. Good evening, everyone. Welcome to the PMRFTA session for the Drug Delivery Principles and Engineering course. This is week 3, and my name is Ashwin. I'll be your PMRFTA for this course. Okay. For any of you who are joining in newly, so basically what we do in these sessions is take a look at previous years' assignments and try to solve them. And I guess last week some people had ask you to go through the week one assignments, and whatever the assignments have finished with their deadlines. So we'll be doing week one assignment this week as well. Okay. So without further ado, let's get into it. Uh, so 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 these are the week three assignment questions from last
Sir,
year.
you are not audible properly. Can you just speak little louder?
Yeah. Uh, is, am I audible now?
yes,
Yes,
so
sir, you are.
Yeah.
can
So
you please expand the presentation slide? It's very small.
the presentation screen is small, is it?
Yes, sir.
Okay, let me see. Is it better now?
Yes,
Not
sir, it is
working.
visible now.
It's better.
Yes,
Okay.
sir, it's visible now.
Okay. Okay. So these are week three questions from last year. So we'll try to go through them and see if we can answer them and see if we have any questions that we are stumbling across. Okay. So which of these two statements are false? So the statements being drug release from reservoir systems is controlled by diffusion. Drug release from reservoir systems is controlled by bulk erosion. Drug release from matrix systems is controlled by diffusion. Drug release from reservoir systems normally follows zero order
Sir,
kinetics.
option B and D.
Option,
B and D.
so D for Delhi and E for Ernakulam. You're saying these two.
B, B and E. B and E.
B and E. Okay, so you're saying drug release from reservoir systems is not controlled by bulk erosion, and drug release from matrix systems does not normally follow zero order kinetics. Is that it? Anyone else has any other thoughts? Okay, let's see what the correct answers are. He, yeah, so he's basically correct. So drug release from reservoir systems is usually controlled by diffusion and doesn't follow bulk erosion, and also matrix systems do not normally follow zero order kinetics. They either follow first order kinetics or higher than first order kinetics, right?
Yes, sir.
Moving on, what are in situ cross-linking hydrogens? Does anyone know?
Sir, option A.
Option A, which is polymers cross-linking at the site of injection inside the body. Okay. Any other thoughts? Can there also be cross-linked polymers that are introduced at the site of injection?
A.
Okay. Yeah. Polymers that cross-link at the site of injection are called in situ cross-linking hydrogens. So, whenever cross-linking happens inside the body, it's in situ cross-linking. Okay. Okay. So, physical hydrogens are polymer networks held together by which of the following interactions or forces? Neutral or ionic bonds, only covalent bonds, only hydrophobic interactions, only van der Waals interactions, only London forces, only nuclear forces, gravitational interactions, or inertia. So hydrogens, there are chemical hydrogens, there are physical hydrogens, right? So physical hydrogens have this
A.
A. So you're saying neutral or ionic bonds.
Yes, sir. Option A is the answer.
Correct. Yeah. So neutral or ionic bonds are usually what hold the physical hydrogens together. Okay. So in microporous hydrogens, pore size usually varies between. So microporous hydrogens have pore sizes of usually the range 100 to 1000 angstroms, 100 to 1000 nanometers, 1 to 100 angstroms, 1 to 100 nanometers, 10 to 1000 angstroms, 10 to 1000 nanometers.
Option C.
So you're saying 1 to 100 angstroms.
Or E maybe.
But 10 to 1000
The
angstroms.
option E is the answer. 10 to 1000 angstroms.
Okay. So 10 to 1000 angstroms is usually a very big range. Microporous hydrogens are usually in the ranges of 100 to 1000 angstroms. So 10 to 1000 angstroms is quite a huge range, right? Okay. So which of the following parameters is an indicator of polymer crystallinity? So we've talked about this last week, I think. Uh, which of the following factors do you think plays
Sir,
is an
PM, PM, option A.
Sorry.
Melting temperature.
Could not hear you. Could you repeat?
PG.
Crystallinity.
Hmm.
So option A, I guess.
Okay. Yeah. The the melting temperature of a polymer indicates its crystallinity. Okay. So, what is the lag effect for release of a drug from a drug delivery system? So, have you guys heard of this lag and burst effects?
B.
The delayed release of drug from drug delivery system after implantation. Okay. Okay, so can you guys tell me why this happens?
So because the some formulations were produced some time ago, and sorry, some formulations have recently produced, and when you implant, the drug will take time to migrate through the polymeric outer membrane.
Perfect, correct. So what is the opposite of this effect?
It's a burst effect.
Burst effect. So which is where like uh, the formulation has been produced and stored for a while, right? And then when you implant it, the drug is already at the periphery, so it comes out as a burst release profile. Okay, yeah, correct. So delayed release of a drug from a drug delivery system after implantation. Okay, what method is used to measure surface roughness? Okay, so how do you measure the surface roughness? Differential scanning calorimetry, two-photon microscopy, dynamic light scattering, circular dichroism, or atomic force microscopy.
It's B maybe.
Which one? Sorry. So you were saying which one?
I'm confused between this B and E.
B and E. Okay. Okay. So the correct answer is E, atomic force microscopy. So two-photon microscopy is usually used to measure pore size and things like that. So yeah, atomic force microscopy is what is generally used to measure the surface roughness. Okay. So which two statements are true for farm? Okay, so these are your week one assignment questions, I believe. So we'll take a look at them as well. Uh, which two questions are, which two statements are true for pharmacokinetics?
Sir,
Pharmacokinetics.
B and D.
Okay. You're saying help
B and D.
B and D. So you're saying pharmacokinetics helps us understand the drug receptor interaction at tissue level, and pharmacokinetic studies how drugs are absorbed or metabolized throughout the body. Am I correct? Is that what you're saying?
A and D.
A and B.
Sir, A.
Okay.
A and D.
Yeah. Okay. Okay. Yeah. The correct answers are A and D. B is not a correct answer. So when you talk about drug receptor interaction, that becomes like we discussed pharmacodynamics of a drug, not the pharmacokinetics itself. So, yeah, pharmacokinetics usually helps in determining dosage regimen, and it also tells you how drugs are absorbed and metabolized in the body. Okay, okay. So, aqueous solubility of three drugs was tested at different pH. Rank them in increasing order of their solubilities at pH 6. So, they've given this graph of chlorpromazine, tetracycline, and indomethacin, and they're asking us to rank.
Okay.
So tetracycline,
The
indomethacin,
option is the answer.
option A. Does anyone else have any doubts or any varying choices? Okay. Yeah, option A is the answer. Okay, so particles of what size can be excreted by kidneys?
Less
Uh,
than 10 nanometers.
The D. The D is the answer.
Less than 10 nanometers. Okay. Others, feel free to speak up. If you have any doubts, also feel free to ask. We can spend more time and try to sort of clear your doubts as well. But yeah, D is the answer. Less than 10 nanometers. Okay. An anti-tubercular drug is administered via two paths, inhalation and IV. The alveolar fluid from lungs was collected at different time points. Please explain the large difference in the bioavailability of the drugs for the different modes of administration. So what they're saying is they've administered this rifobutine drug either through inhalation.
The
So
option C.
option what?
C, C.
Okay. Yeah, so they've administered this drug either through inhalation or IV, and they observed this very drastic difference in in the bioavailability. So they're asking why there's such a huge bioavailability.
Going
Uh,
directly to the lungs, the B. The C, C.
yeah, so if the option C is the bioavailability of inhalation route is higher for lungs and is hence reflected from the lung fluid. Yeah, which is what you would expect. It's correct. Okay. So which of the following will have higher partition coefficient?
A.
Why?
Sir, A is the answer because the size is very much large and six carbon chains are there along with the carboxylic acid. So means it's joined by five different carbon atoms. So that's why it has large partition coefficient due to large size.
So, okay, so you're saying
A
because
large
of,
number of carbons, so it will be more soluble in organic phase. So CO by CW will be higher.
correct. Yeah, yeah. So it's not necessarily because it's of a large size. It's because it's more it's more hydrophobic in nature. So this long chain is more hydrophobic in nature. So that's why it has a very high partition coefficient. Okay, which two statements are false for partition coefficient? The ratio of concentrations of a solute in two immiscible liquids when it is in equilibrium across the interface between them.
So B and D.
B is the higher the liquid water coefficient, the greater the rate of transfer across the membrane. Okay. And D is lower the polarity of drug, higher the lipid water partition coefficient. Okay.
C and the higher the lower the polarity, higher the one is C,
Okay.
higher the liquid water or the sorry, one is B actually, higher the liquid water, the greater is the rate of transfer. False, right?
So the liquid water coefficient, the lower will be the rate of transfer because they're inversely related to each other. And for E also same will be the reason. Both are inversely related. So B and D are false.
Okay. Any other?
C and D.
Okay, so it's actually C and E. So uh, the higher the lipid water partition coefficient, the lower the rate of transfer across the membrane is false. So yeah, so if you have the higher the lipid water partition coefficient, the higher is the transfer across the membrane, right? Cell membrane. It is easily able to pass permeate through the cell membrane, and similarly, the higher the polarity of the drug, the lower will be the lipid water partition coefficient because if it's highly polar, it's more soluble in water. So makes sense or
Yes, sir, correct. These are false.
yeah, C and E are false, not B. Okay, okay. I guess I'm giving the answer here. But which of the following two statements are true for bioavailability? Okay, so bioavailability, once again, to sort of reiterate, it's the total amount of drug that's readily available in the body. So it can be calculated by calculating the area under the curve by plotting the serum concentration of drug over time, and also bioavailability, as we've been hammering, is 100% when drugs are administered intravenously. So all the other options are wrong. For some reason, so I don't know how many of you have answered as the first option, but in the website somehow it says it refers to how much drug is available in shops is also correct answer, but it's not. It does not depend on the route of administration. It refers to the amount of drug that is. It does not refer to the amount of drug that is lost in the first pass metabolism, and it does not also not depend on the drug physiochemical properties. So it depends on the drug's physiochemical properties. Okay. Okay. So yeah, there are a bunch of numericals uh, that you guys had in your first assignment. Okay. So do you guys have any doubts in the numericals? Okay, I'll just go through
Yes, yes,
the.
sir. In assignment 3, there was one numerical was the regarding the size, 10 to the power 6, 10 to the power 9. Can you calculate that for us? Yes, we have already submitted the correct answer, but I was having some doubts regarding how to calculate.
Oh, okay. Let me see. So assignment three deadline has passed, is it? Okay. We'll check. We'll go through these and I'll open the website and we'll check. Okay. So a drug
Sir,
ha yeah.
I also have problem in assignment 3, question number 9.
Okay, so is the assignment 3 deadline over or is it to
Yes,
pass?
sir, it's over. The deadline was 18th.
I see. Okay, we'll check.
Okay.
Yeah. So you guys were fairly comfortable with these, is it? Any of you have any doubts with these numericals before we move on and open the assignment 3?
Sir, please calculate.
Okay. Okay. So we'll go through the questions anyway. So a drug has a half-life of 30 minutes in its native form. Okay. PEG is conjugated to the drug to improve its pharmacokinetics, and the modified drug is injected intravenously with an initial plasma concentration of 1 mg per ml. After 12 hours, the concentration of drug in serum is 0.5 mg per ml. So here what you have to recognize is that so after 12 hours the concentration is halving. So which means that they're giving you a new half-life. So this 12 hours is nothing but the new half-life. The old half-life was 30 minutes. They are just asking you to calculate the change in the half-life. So all you have to do is convert the 30 minutes to hours and calculate the difference. So change in half-life is 12 hours minus 0.5 hours, which is 11.5 hours. Okay, so this type of problem we have done previously. So they'll give you a mixture of different moles and molecular weights of polymers, and they'll ask you to calculate the polydispersity index, right? So first you have to calculate the number average molecular weight of the polymers, the weight average molecular weight of the polymers, and once you have that, you essentially divide the weight average molecular weight of the polymer by the number of average molecular weight. It should be 1 or greater than 1. Yeah. Okay. So a drug A is injected into a patient. The rate of elimination of A is 25 grams per minute and its plasma concentration is 5 grams per ml. What is the rate of clearance of drug from the body in liters per minute? Assume that drug distributes in total body water. Okay, fairly straightforward. So clearance is nothing but rate of elimination over the plasma concentration. So you just convert them to appropriate units, and then you'll get 5 liters per minute. Make sense? Okay. So let me. Um,
Sir, can you go back to the first numerical,
yeah.
the slide? This one.
Yeah.
Okay, thank you.
Okay. Yeah, so basically you'll have to recognize the fact that this is the new half-life because the concentration is high.
Sir, in assignment 2, there was one numerical. Can you please solve it? The
Okay.
deadline is already over.
Okay, let me see. Uh, Let me go online and
This, this assignment 2, number 9. Consider a microsphere of diameter 1 micron.
right. Let me go online first. Let me try to access the course. So assignment 2, you're saying, so consider a microsphere of diameter 1 micrometer. That's the one you're asking?
Yes, sir. This
Okay. And what's the other problem in assignment 3?
The question number 9.
and there was also one doubt regarding the heat capacity, sir. In it is both degree centigrade and 1 Kelvin. Both options were there, but in 1C no degree was mentioned because you have to when you are writing C centigrade you have to mention the degree sign. And 1 Kelvin was also right because change in 1 unit temperature either in Kelvin or degree centigrade.
Okay, let me see. Let me see.
So those who have selected 1K, it is coming as a wrong answer.
I see. Okay, let me see. So so if it's so about this degrees Celsius and Kelvin question, so you can raise a query in the so you know the forums that where you can ask questions, right?
Okay.
Yeah, so there you can raise a query, and one of the course TS will answer you and try to figure out what's happening there.
Okay, so someone has already raised an query regarding this question.
Okay,
Can you ask Rachit sir to look into this, please?
okay, sure.
And this numerical regarding 1 micron, because when I was calculating it is coming 10 to the power 6, but the option is not there.
Okay, so we'll do the numerical now. Uh, okay, we'll do the numerical, no problem. Which require to. Okay, so I see what you mean also. So you're saying there's this. What is the heat capacity of the system? You're saying there is two options that say 1C, right? Heat required to increase temperature of the system by 1C. Heat required to. Let me share my screen.
The question number 6 of assignment 3.
Correct, correct. Yeah. Discussion, right? Hello.
Yes, sir.
Yeah. So what's the problem here? So you're saying it could be both by 1 Kelvin or 1C.
So it is actually 1 degree centigrade, but the degree sign is not there because when you are writing centigrade, you have to mention this degree sign always. And
Correct.
one in some books it was also written 1 Kelvin also.
Okay. Okay. So the problem I think with degrees centigrade is the software itself. Maybe the TA has missed to put a degree sign there, but it's supposed to be 1 degree centigrade. But yeah.
Was
Okay.
I was confused because as the degree sign was not there, so I choose 1 Kelvin, another option. Now it is coming as wrong, but in one book I thought it was also 1 Kelvin unit change.
Okay. So yeah, I don't think it's 1 Kelvin unit change because 1 Kelvin unit change is quite large. So one degree centigrade, but okay, we'll see. I'll talk to other TS industry and see what happens.
Otherwise, if the degree sign was there, I have chosen this degree centigrade because it was the proper actual answer.
Right, right.
Most of
Okay,
the books say it is degree centigrade.
right. Okay, okay. Let me see. Let me talk to Vishal and see what he says, and yeah, we'll figure out.
And another one is this numerical regarding micron, sir, because please calculate this question number 9 of unit, this assignment 2.
This one.
Yes, sir.
Okay. Uh, okay. Consider a microsphere of diameter 1 micron. Calculate the
What is the formula actually? So 1.49 I am getting, but it is somehow I am getting 10 to the power 6. But
Okay, okay.
missing something or not? What I am missing actually I want to know.
Yeah, yeah. We'll calculate. So someone said there's one more question. There's one more numerical on assignment 3 that they wanted to calculate.
So, question number 9 of assignment 3.
This one. What is true for bioerodible matrix system delivery systems? Okay. What is the doubt?
Sir, I need clarification on the options which so correct can achieve first order with surface eroding polymer device.
What is true for bioerodible matrix delivery systems? Okay. What is the doubt?
Sir, I need clarification on the option, second options, which is right, can achieve first order with surface eroding polymer device.
Okay. Can achieve first order with surface eroding polymer devices. Okay. Okay.
Sir, because in the notes it's mentioned that can achieve zero order with surface eroding polymer devices.
I see. Oh, so it says can achieve zero order. Let me check. Let me open the notes also.
Sir,
Yeah.
actually, I have doubt with the same question only because in notes only it was written zero order kinetics, but in answer it was showing first order kinetics. Means my answer got wrong because I have selected the non byproducts one because it was written first order kinetics, but in note it was written zero order, so that's why.
Same
Okay. Okay.
happened with me, sir. I'm raising query as well.
Okay. Okay. Let me check. Let me check. Let me open the notes also. Yeah, you can raise this also as a query in the forums. It does say that surface eroding polymers can achieve zero order release. So please to raise a query. Hello.
Yes, sir.
Yeah, I'm saying please to raise a query in the the forum, because it does say that surface eroding polymers can achieve zero order reaction, zero order release. So yeah, you're referring to this slide.
No, sir. Yes, sir.
Yeah, so same thing. Uh, Zero order release can be achieved using surface eroding polymers. Yeah, please raise a request. Yeah, yeah, it does mention here also zero order release.
Yes, sir.
Yeah, raise a request and we'll see why, why this has happened. Okay. Okay, so you guys can see my screen?
Yes, sir.
Okay. Okay. So consider a microsphere of diameter 1 micrometer. So we know diameter is 1 micrometer, which means radius is 0.5, right? Okay.
Can you please increase the size of the slide, please? Because it is too small. I can't see. Yeah, yeah, okay. Thank you. Thank you.
Yeah. So we know the diameter is 1 micrometer, so radius is 0.5 micrometer. Calculate the number of such particles that will be present in a 1 mg given the density of the material. Okay, we know density is 1.3 gram per ml. Okay. Yeah, so radius is, and so now we know volume, right? So volume is, how does volume relate to mass and density?
So m equal to Vt. If you try, then the you have to calculate 4 by 3 pi r cube. You have to calculate the volume of one microsphere.
Correct. So there is a relationship between density, mass, and volume, right? Volume is mass by density. Do you guys remember? Volume is equal to mass divided by density. Correct?
Yes, sir.
Okay. So we know mass, which is given as, sorry, I'm just pointing it, which is given as 1 mg. So if we need to convert it to grams, 0.001, right? grams divided by the density is 1.3. 1.3 grams per ml or centimeter cube, more or less is
Yes,
fine.
yes.
Yeah. So this is how much. Some value. Uh, so now we know the volume, right?
69 10 to the power minus 4.
Sorry?
E to the power minus 4 it is coming. 10 to the power is 9 means 10 to the power, right?
Yeah, yeah. So this is to the power of minus 4. That's fine. Yeah. So now we know this relationship, right? N into volume is equal to mass over density. So this will be volume of sphere here, right? What is N?
Yes. Number of microspheres.
Correct. So volume of a single sphere is what? Volume of a
2
sphere.
the fire cube.
Correct.
Means to 2 the fire cube, sir.
Correct. 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 So yeah. Do you guys want me to do the math also? Okay. Into 4 by 3 4 by 3 pi r cube. So 0.5. So we need to convert this to
We have to convert this into
centimeters, right? So 0.5 into 10 to the power of uh, 10 to the power of minus 4, right? Minus 4 centimeter. This thing is 4 to the power of cube. So cube to the power cube. Uh, 4 by 3 pi r cube is equal to, so we know the density 7.6 into 10 power minus 4. Okay. This value and just substituting it. Okay. So now n is equal to, okay, I'll have to open the calculator. 4 by 3 into 3.14. 4.1 into 10 to the power of
-12.
minus 12, right? This 12 is equal to 7.692 into 10 to the power of minus 4. Okay, I'm just going to remove this. Okay, so I'm going to cancel minus 4 here. And take the entire thing that side. So 7.418 into 0.5 0.5225. So 14.72 something. So n is equal to 14.72 something into 10 to the power of 8, right? Particles.
Yes, yes.
Otherwise 1.47 1.472 into 10 to the power of 9 particles. Okay, what are the options? One
Okay, I got
point,
it. Okay,
yeah, 1.47 into 10 power 9. Yeah, 1.469 into 10 power 9 is the correct answer. Is it clear or are there any questions?
got it. Yes, clear now. Clear.
Okay. Okay. Anything else you guys had doubts in? Okay. If not, we can end the session today. Uh, so we will take a look at week 2 and week, yeah.
In assignment 1, first question, you had given the right options as A and D by two statements.
Assignment, sorry, which assignment?
Assignment 1.
Assignment 1. Okay.
First question.
This one, right?
Yes.
Okay.
Uh, Option A and B as the right option.
Option A and D are right. Yeah.
But the PK studies, option C, PK studies are used to identify new drug targets.
Are they?
If you look at the slide, which shows pharmacokinetics and pharmacodynamics comparisons.
Okay. Let me open that.
Earlier slide,
Yeah.
it shows the pharmacokinetics, design of dosage regimen, where, so that should be the drug targets, right?
Design of, what does it say?
Design of dosage regimens under pharmacokinetics.
Yeah, so design of dosage regimen is basically determining like how often you need to take a drug. So if you go to a hospital and doctor says take paracetamol 3 times a day, that's the dosage regimen.
That's option A.
That's optional.
That's fine. But the second one,
Okay. So the second one, which is,
shouldn't it be part of pharmacodynamics?
yeah, it is pharmacodynamics. So this is not
Question
pharmacokinetics.
is pharmacodynamics. So the option C should be the right.
No, I'm still confused why you think option C is the correct option. Let me open the,
Because if you see design of dosage and where it is administered is also under pharmacokinetics.
yeah, so where it is administered in the sense, like what route is it administered in? So when you're trying to identify new drug targets, that's a different story, right? So you'll have to, so identifying new drug targets is basically identifying which receptor the drug can go and attach to and modify the receptor. So it's completely different compared to the dosage regimen and from where the drug should be given and so on and so forth.
I'm just trying to see because all the other options are not closed.
All the other options are,
In B should to how drugs are absorbed and what the body should be related to pharmacodynamics.
so you're saying this is related to pharmacodynamics?
How drug is metabolized.
No, so that's what. So an easier way to look at this is what your body does to the drug is termed as pharmacokinetics, and what the drug does to your body is termed as pharmacodynamics. So whenever your body is doing something to a drug, so whether it's absorbing, metabolizing, excreting, all this come under pharmacokinetics. when the drug is having an effect on your body, so for example, whenever it's going and binding to a target, whenever it's blocking a receptor, or whenever it's activating a receptor, all these come under pharmacodynamics because the drug is doing something to your body. Yeah. So whenever your body is doing something to a drug, it's pharmacokinetics. So how a drug is absorbed, how a drug is metabolized, how a drug is excreted, all this come under pharmacokinetics. Uh, a- and yeah, so I'm still not sure why you think identifying new drug targets it comes under pharmacokinetics because so see how do I put this? So identifying new drug target means like you're able to sort of conduct assays where you're able to sort of pinpoint to the receptor where the drug goes and binds to, right? So you're talking about the action of the drug, not the action of your body on the drug. So pharmacokinetics is the action of your body on the drug, irrespective of what the drug is. Yeah. Any other questions? Okay. If not, we can end the session.
Thank you, sir.
Sir,
Yeah. No.
in week 2, question 6,
Okay.
should it be non-immunogenic instead of immunogenic?
Let me see. Let me see. We do question 6. What are the advantages of using polyethylene glycol in drug delivery application? That's the question.
Yes, sir.
Okay, so has been developed conjugation chemistries, non-toxic. Yeah, it should be non-immunogenic. I guess that's a typo. Yeah.
Yeah, so I got it wrong because I thought it was the wrong option. So,
Okay. Please raise a forum query again, and
okay, sir.
yeah, someone will.
Thank you, sir.
No problem. Okay. Thank you, guys. Thank you for joining in. See you next week.
Thank you, sir.
Yeah.
Thank you, sir.